Good morning. I'm obviously not James, but I'm here to present a portion of his PhD research that he conducted in our lab. The basic objective of his study was to use eDNA metabaric coding approaches to look at the structure of fish and macrovertebrate communities in acid mine impacted streams, and also use leaf litter bags to associate that with the characteristics of the macrovertebrate community to kind of get a proxy for carbon cycling in the system. I'd like to acknowledge our collaborators, the Wilds, in particular Stephen Spear, who helped us with the study design and navigate the Wilds at the time, and also the Ohio State University, for especially the Robert H. Ederle Ecotoxicology Fellowship, who supported James. So our study site basically comprised 3 different reaches on first and second order streams. On the far left-hand side, you see the typical rust-colored flocculates and precipitates associated, low pH associated with high acid mine drainage streams. We also had low AMD stream and a reference site from another tributary in the watershed. At all these sites, we measured standard water quality parameters as well as metals, and conducted backpack electrofishing at the low AMD site and the reference site. We took 3 replicate 1 liter water samples at each of our sampling times. I'll talk about litter bags more in a second here. We sampled for 4 months and took samples at each of those times and used the 12S MyFish, the CO1, 16S, and ITS primers to look at the sequences. The leaf litter bags were made of plastic meshing. You can see them there in the stream with 4 grams of cotton leaves packed in there. There were 16 of these at each site, and so we sampled 4 at each sampling time. So 3 for looking at the litter decomposition, measuring the acid-free dry mass of the leaves when we took them out, and then extracted 1 of these litter bags for eDNA. The results, electrofishing and water eDNA were approximately the same in terms of the species detections. This is combined data for the low AMD and the reference sites. But what was interesting was the leaf litter bags picked up about 75% of the fish species we also found in the other methods. We also detected 19 other species in terms of bycatch, which is pretty cool. All the mammals you would expect in the system: white-tailed deer, beaver, muskrat, red squirrel, but also a number of bird species. We had wood ducks and mallards you'd expect, but we also got some corvids, blue jays, and crows, and a number of passerine songbirds. Looking at the leaf litter decomposition results, leaf litter decomposition was obviously inhibited here in the high AMD site compared to the low AMD and reference sites. And looking at a heat map of the genera, we detected 14 unique genera of arthropod invertebrates here at these sites. And you can see that we have the samples for each of the times split out, so 4 leaf and 4 water samples for the low AMD and reference sites. And the reference site was obviously the highest number of taxa present, and the leaf litter seemed to work quite better than the water sampling for detecting these taxa, which is not unthinkable. We kind of collapsed the high AMD site into 2 columns because there basically isn't a whole lot there. Looking at relating functional feeding groups to these invertebrate taxa we found, you can see on the far left-hand side there, the high AMD site lacks that pink bar on the histogram, so that indicates an absence of the collector filter feeding gills. And you can see that also that there's a significant increase in the number of taxa you see at the reference site compared to the AMD sites. The graph on the right side depicts that the leaf litter technique is much better at detecting the various groups of invertebrates than the water sampling technique. So highlights, leaf litter decomposition was impaired at high AMD and was reflected by the taxa we detected in the gradient with lower taxa from the AMD site to higher at the reference site. The metabaric coding approach in the leaf litter outperformed the water metabaric coding approach for macrovertebrates. And by combining all the different eDNA methods and the traditional surveys, we were able to expand the taxa list of the mammals or the vertebrates that we found at these small streams. So it gave us a good increase in the number of organisms we could find in these sites. Thank you. I'd be happy to talk about this during coffee.